And you were to cancel.
Okay, so one of the things we didn't do yesterday when we were talking about trigonometry and working with triangles is we never calculated angle measures. We looked at all kinds of triangles, solve for side lengths over and over and over again. So the simple question today is, what happens when we have that triangle, and I would like to know, for instance, how big angle P is. Pretty straightforward calculation. Since the trig things that we're working with are functions, then we get something called an inverse function. What's an inverse function? Good. So what's the inverse function of addition? Subtraction. What's the inverse function of squaring? Square root. Okay, so they undo each other. For instance, what's the square root of x squared? X. You get back to where you started. Right? Okay, so everybody's good with the idea, right? If you look at your calculator, above the sine, cosine, and tangent button, there are the inverse functions. They look like this. Sine to the -1, cosine to the -1, and tangent to the -1. Those are not reciprocals, they're inverse functions. If you did okay on yesterday's homework, then this should be really easy. In other words, if you can set up the equations like you were supposed to do in the homework yesterday, then the inverse is pretty straightforward because you're just going to undo stuff. Okay? So for instance, if I go back to this triangle, the sine of angle A is 4/5. Okay, that's yesterday's stuff. Opposite over hypotenuse, which gets me to that guy. Now, how do I get rid of the sine?
Divide.
No, not divide. Inverse sine. Okay, now, the way to remember not dividing is the same way that you remember if I want to undo a square. Okay, I've got x squared. If I want to undo the square, I don't divide by squared. Okay, that makes no sense. If I want to undo a square root, I don't divide by square root. Same thing is true here with the sine. I'm going to take an inverse sine of this side. And if I take the inverse sine of one side, I have to do the same thing to the other side. What's the inverse sine of the sine of A? What's the inverse sine of the sine of A?
Wild guess. 53.1?
No.
No.
You're not answering my question. You're answering the question you think I'm asking.
That guess is 0.92.
What's that?
Nothing.
You just rambling again?
Yeah.
Okay.
0.8.
Well, hold on. Listen to my question first. What's the inverse sine of the sine of A?
A.
Thank you, Peter. Just A. Now, how do you find the inverse sine of 4/5?
Times 5.
Just plug it into your calculator.
53.1.
The inverse sine is above the sine button, so you do second sine, which will give you the inverse. Put in 4/5, close parentheses correctly. You should get 53.1 degrees.
Yeah, that makes sense.
Okay. If that's 53.1 degrees, if I go back, how big is angle P?
Or no.
It won't be an exact answer.
It'd be
36.9.
36.9.
36.9, correct. Because E plus A plus P have to add up to be 180 degrees. Could we have used an inverse function to solve that? Yes, we could have, but we're working smarter. Okay?
Wait, how do you get like that answer for?
Inverse sine, which is above the sine button, of 4/5. Have the calculator do a little.
P.
Oh, they took 180 minus 90 minus 53.1. That's so three angles have that. Question?
How do you,
Do you
Wow,
use the
I
stored
figured
function?
that out.
Go ahead.
Just use the stored value of the angle that we just found to find p.
Yes, but you'll still get the same answer in this case. Okay? Solving the triangle. That means when I'm done with this problem, I'll know all 6 parts of the triangle. You'll also notice I didn't give you a picture. I'm going to have to draw my own. Doesn't have to be 100% accurate, but it should be a right triangle. Where do A, B, and C go? Capital A, capital B, capital C.
Opposite of the sides.
Okay, so what vertex is this? Could be B, we'll make it B. What vertex is this?
See,
C, that has to be C, that makes that A. Okay. How long is this side?
18. Or wait, no.
How long's the hypotenuse, in other words?
Lowercase c.
Lowercase c, we don't know, so we're going to call it lowercase c. How long is this side? 18. This side? 13. Okay. I know 3 chunks of information. There are 6 in the triangle. Let's start with the easy one. How are you going to solve for C?
15 squared plus 18 squared.
Also known as
Pythagorean.
Pythagorean theorem. Solve the Pythagorean theorem. Tell me what C is, please.
22.2.
Okay. 22.2 is the suggestion on the floor.
Yeah.
We have confirmation. Does that make sense?
Yes.
Okay, good, because it's the hypotenuse, so it's got to be the longest side. Is that an exact answer or a calculated answer? Calculated, so we're staying away from it. I'm going to put a rectangle around it because it is one of my answers that I'm looking for, but I'm not going to, if at all possible, I'm going to avoid finding or using that in a calculation. How are we doing so far? Nothing new, right? Beautiful. So, which angle, Addie, would you like to solve for first? A or B? B. Any particular reason? Okay. She wants to solve for angle B. I have to set up a trig equation. Addie, which trig function would you like to use? Sine, cosine, or tangent? Nope. So, why can't we use cosine?
Because that involves the hypotenuse and we don't know.
Because that involves the hypotenuse and we don't know. So what 2 sides do we know? Which are opposite, adjacent, hypotenuse. Which 2? Good. And which function uses adjacent and opposite? Tangent. Beautiful. Okay. So set up an equation. Tangent of angle B is equal to, Addie, 18 over 13 or 13 over 18?
18 over 13.
Well done. You'll notice I left a weird gap in there after the equal sign. You'll see why in a second. Carl, how do I solve for angle B? How do I get B by itself? Oh, hold on.
Never mind.
B by itself.
By base 10.
Close enough. We're going to multiply by, well, we're not actually multiplying, but we're going to use the inverse tangent. I'm going to take the inverse tangent of this side, which means I have to take the inverse tangent of this side, and you'll see why I left a gap in there, because you have to put the function before the values.
Oh, not bad, yeah.
What's the inverse tangent of the tangent of B?
54.2.
No. What's the inverse tangent of the tangent of B? B, thank you. In other words, this side simplifies to angle B. This you do on your calculator. What's the inverse tangent of 18/13?
54.2, rounded up 6.
54.2?
Yeah.
Okay, sounds like we got enough confirmation there. That's a degree, so I'm going to put a degree symbol after it. Now the fun part. You ready for this? We have, oh, I'm going to put a rectangle around that too, just because that's my other chunk of information. I got one more chunk of information to find, and that is angle A. There are at least 4 ways to find angle A. 3 of them are a pain in the rump. 1 of them is easy. Molly, how would you find angle A?
Add 90 because that's the angle of C, and then you add 54.2.
Beautiful. That's the easy way to do it. Well done. Angle A would be equal to 180 minus 90 minus 54.2, which gives us what, Mal?
Oh, I got 35.8.
35.8. That's also degrees. Well done. The other 3 ways you could find angle A would be using trig values. You could do a tangent. You could do a cosine, but that would be adding calculated information. Wouldn't be real happy about that. You could do a sine using calculated information, but I would argue that that is by far the easiest way to do it. Okay. Solve all 6 parts. The 3 stuff I start, 3 sides the 3 pieces of information that I started with, calculated 3 others. Make sense? Beautiful. All right. Let's take a look at a flagpole problem. So when we were talking about the flagpole problem yesterday, and some of you came up with great ideas on how to find its height, and some of you came up with some wonky ideas to how to solve the height. One thing we didn't talk about is how are we going to physically measure the angle. So some of you said, well, we'll use a protractor, which is fine, and we will use a protractor, but we still didn't address the physical act of using a protractor to measure the height of a flagpole. One of the things that we neglected to talk about is in order to measure the angle, you got to get your face down on the ground, because your eye has to be down by the ground in order to measure the angle. However, I set up this problem a little bit differently to make your life a little bit easier, because the ground is all gunky and you probably don't want to be flopping around in the snow. So I took into account the fact that your eyeball is 5.5 feet off the ground. By the way, there's certain assumptions we make when we do word problems like this. We're assuming that you don't have one leg shorter than the other. We're assuming that the flagpole is perpendicular to the ground. We're assuming a lot of perpendicularity here. How long is this? Huh? Why?
Like where your eyeball is.
Exactly. If I look straight across at the flagpole, I will look at a point 5.5 feet above the ground. I would argue that this is easier than putting your face down in the grass or the dirt or the snow or the slush. Let's call this X. In a second, we're going to go through the calculation to find out how big X is. But what do I need to do to answer the final question? How?
By finding X and adding 5.5.
Beautiful. Find X, Gesundheit, and add 5.5. Does everybody see that this is a right triangle? Yes? Okay. What shape is this? Rectangle. So therefore, how long is that segment? 100. It's the same length as the distance you are away from the flagpole. So we got a nice little rectangle down there at the bottom. Kayla, what function would I use to find X? Sine, cosine, or tangent? Hold on, sorry. My bad. We know that angle. Okay, now what function would I use? Nope.
Tangent.
Yes. Why not cosine?
Because it requires the hypotenuse, which we don't know.
Beautiful. Okay, so what equation would I set up?
I don't know. I'm not sure.
TJ? What equation would I set up using the tangent? I'll get you started. Tangent.
The opposite.
Hold on, tangent of what? Don't pull a Wendy here, we need to take a trigonometric value for an angle measure. Don't look at me in that tone of voice, I'll knock you into tomorrow. 37.5 equals x over a hundo or a hundo over x? X over 100. Solve for x, please, peeps. Oh, notice, no inverse on this. Because I already know the angle measure. It's just a straight up calculation. Yeah.
Are we just looking to find x?
For now, we're just solving for x, yes. Lou!
I got x equals 134. I mean,
Uh-oh, they turned on you like pit vipers. Holly, what'd you get?
I got 76.7.
76.7? That's for x, wait, that's for x, right? Okay.
Negative number?
Don't worry, little bit happy.
Oh, I did a silly.
So what's the height of the flagpole?
82. No, it's not. 82.2.
Right. By the way, when we get to word problems,
Oh, I got that. I did it.
when we get to word problems, make sure that you're using units for your answers here. 82.2 what? Feet, inches, yards, miles, light years?
Feet.
Yeah, these are feet. Good.
I'd like to use like
Because then you add
Okay.
Because you
Is
get
that a
high
reasonable
point five.
answer for the height of the flagpole?
Yes. Yes.
Wait.
Do you have any idea how far off the ground you are
How
now?
do you get 3?
Like really far. Yeah.
37.
About
That's
how
an
much?
angle.
How do you get that?
5
So
feet.
it gives them problem.
No.
It doesn't work.
You're on
Sorry,
the
you
third
didn't
floor.
understand. Right now, you're on the third floor.
Oh, yeah.
Do you have any idea about how high off the ground you are?
Like 30 feet.
I agree.
It's about somewhere between 20 to, well, 25 to 30 feet. Yeah. Each story in a building is about 10 feet high. So that's a flagpole that's 8 stories high. Is that reasonable?
Sure.
All right, good.
I mean, based on this calculation.
There's big flagpoles, small flagpoles.
Based on reality.
And then there's math.
Solve for x.
Okay, gotcha. No more step, I got you. So.
It's like 5. No, alright. But you know what the slope is.
Where's the height column? 51.3. Where's the height column? So cosine is the which is 10 over the hypotenuse.
Inverse.
And then you do the inverse.
Let's go see
Hold on, we're not packing up yet. What's x?
Yeah.
You think so?
Yeah.
I know so. Last thing, this will go a lot quicker if you're quiet, Jess.
So you use x as the angle, and then it's the hypotenuse minus the opposite.
Jason. Yes. Okay. Last thing, we talked a little bit about this in problem number 2. However, you should be able to answer a question like this without your calculator. They did it. In problem number 2, wait, you may have done it also. Those values come from those triangles. Set up your trig ratios, make sure you cancel your variables. You're good to go. Day 5 for homework. Quiz on Thursday. Have a nice day, everybody.
He sent me home yesterday. That's why you weren't there? I was in a cardio room with my wife.
That's where